Hello, my name is Ross Kim Shrek, and I'm here to present my project for week 10. So I'm going to share my screen with you. Okay, so I'm first going to talk about the problem. So the problem in this scenario is that financial institutions are experiencing increasing number of fraudulent activities. This includes like unauthorized credit card transactions, suspicious account activities, and this could be indicative of money laundering. So here are the technologies that I'm going to be using to tackle this problem. The first one is HDFS, which is Hadoop Distributed File System. I'm going to use it because it has a very high throughput access and it's a very scalable storage. The second will be Yarn. This will be used to allocate resources to applications in Hadoop clusters. It's also good for scheduling tasks. The third one will be Hive, which is a data warehouse system. This will also analyze data at large scales and also querying. The next one will be HBase. This is good for big data storage. It can also read and write transactional data in real time, and it can access large sparse data sets. I'll be using Spark, which is an open source distributed processing system. It's good for real-time processing and analyzation of data. It also detects fraudulent transactions, and it's fast in querying and analytics. I'll also be using Kafka, which streams data in real time. It's good for storage and analysis of its historical and real-time data. I'll be using Solr for fast and real-time monitoring. It's good for document retrieval as well. And lastly, I'll be using NiFi. This treats a series of events as flows. It's good for data ingestion, especially, and flow management, and it's great for processing big data. So here's the process. I'm going to start, of course, by gathering the data from, for example, credit card transactions and suspicious account behavior with people using their accounts. And this will be ingested into NiFi. I'll be using NiFi Canvas. So I'll use NiFi to generate and log the data and then filter those logs, and those logs can be converted to JSON for later processing. This data will be published into Solr, and then I'll create collections in Solr, and then start the flow in Solr. So then after the ingestion of data into NiFi, the data will be moved on into Kafka for real-time streaming. In Kafka, I'm going to create partition topics for the data, and this will be across multiple instances. So I'll run performance tests, and then I'm going to create produced and consume messages in real time. And these messages will of course, be the streaming capabilities of Kafka. And we can then communicate any transactions with customers and clients. And then from Kafka, we'll move into Spark, where the data will be transformed using the Spark Scala shell. In Spark, I can run SQL queries on tables in the data, and I can process the data in real time and use analytical skills in Spark. This can be directly applicable to managed services such as AWS as well. Then I'll move on into Hadoop, which is HBase, where I'll have to create tables and populate those tables using the data. After this is achieved, I can query and retrieve details on different aspects of the data tables. And this also can be extended into other storage solutions. So then moving on into HDFS, where I'll create yarn nodes, inspect those, and I can modify the memory allocations by using a yarn scheduler. Um, I actually tested this in MapReduce earlier, where I tested Pi. Um, and this data will be retrieved into HDFS from Hive, from Hadoop. Then moving on to Hive, once again, I'm going to have to create tables and load the data sets into those tables. In Hive, I can then run SQL commands on the data sets, and these data sets will be loaded into HDFS after that. And then finally, in Solr, once the data is in Solr, I can run advanced queries um, through Solr's interface. I did this earlier. I ran faceted searches on different aspects of data tables. Uh, I can run queries um, on custom JSON data that was previously generated. I can create Solr collections from NiFi um, as well. And then the final steps here, this is deals more with like storing the data, but I'll use HBase. HBase is good for fraud detection because it can access real-time transactions. I can also read and write operations for detection and create necessary data tables using Kafka. Then onto HDFS, where the data will be retrieved and stored, and it will be retrieved from Hive. In Solr, I'll use it for querying, necessary querying that can be done very quickly. And this data will be retrieved through collections from NiFi. And then I'll be using Hive to process the batches, and I'll run analytical queries, and then that data will be loaded into HDFS. So in conclusion, the financial institutions, if they use this method, I feel that the good thing about it is this architecture will be very robust and scalable. It's going to be very fine-tuned for large amounts of data. This will enhance fraud detection in real time using these technologies while adhering to industry regulations. Okay, that concludes this presentation. Thank you very much for listening, and have a great day.